Row 1. Text, Notepad window, text editor, editing, blank. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes and listen. Based on G scheme for Electronics Engineering Group. Subject, Digital Communication, 17,535. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Digital Communication Chapter 5. 1. C. How does FDM technique combines multiple signals into one? ANS, FDM diagram, 2 marks, explanation, 2 marks, frequency division multiplexing, FDM, is based on the idea that number of signals can share the bandwidth of a common communication channel. The multiple signals to be transmitted over this channel are each used to modulate a separate carrier. Each carrier is on a different frequency. The modulated carrier are then added together to form a single complex signal that is transmitted over the single channel. Fig below shows a general block diagram of FDM system. Each signal to be transmitted is fed to modulator circuit. The carrier for each modulation FC is on a different frequency. The carrier frequencies are equally spaced from one another over a specific frequency range. Each input signals given portion of the bandwidth. Another standard modulation like AM, SSB, FM, or PM can be done. The modulator output having sideband information is added together in a linear mixer in which all the signals are simply added together algebraically. The resulting output signal is composite of all carriers containing their modulation. This signals transmitted over single communication channel. C. With a neat sketch describe the working of OFDM multi-carrier system. ANS diagram, 4 marks, explanation, 4 marks. Figure below shows the conceptual diagram highlighting the orthogonal, OFDM, multiple carrier modulation scheme. The S in the diagram indicates the modulating signal in the I path, and the S are the modulating signals in the Q path. The encoder in a practical system performs several operations, but if of no special significance at the moment. All the cosine modulated signals are added algebraically, and similarly are the sine modulated signals. The overall I phase and Q phase signals together form a complex baseband OFDM signal. At this point, one may interpret the scheme consisting of a bank of n parallel QPSK modulators driven by n orthogonal subcarriers. A useful feature of OFDM modulation scheme is that pulse shaping is not necessary for the modulating signals because a bunch of orthogonal carriers, when modulated. Digital Communication Chapter 5. 2. By random pulse sequences, have a orderly spectrum as shown below. As indicated, the orthogonal subcarriers occupy the spectral zero crossing positions of subcarriers. This ensures that a subcarrier modulated signal with seemingly infinite spectrum does not interfere with the signals modulated by other subcarriers. Digital Communication Chapter 5. 3. C. Compare TDMA, FDMA, and CDMA techniques based. I. Definition 2, bandwidth available 3, synchronization 4, application. ANS, each 0.1 mark. A. Describe the North American digital multiplexing hierarchy, with neat diagram. ANS, diagram for marks. Explanation, for marks, the first digital signal in true sense is the Pcm voice signal. A Pcm voice signal represents 64 bits/section, i.e. 8000 samples/second *8 bits per samples. Such a signal is called as digital signal at level 0, DS0. It is also called as T1 signal. Due to 8000 samples/second sampling rate, the time duration between adjacent samples will be 125 section. But practically DS0 signal is not transmitted, because most of the telephone lines are analog. Hence in telephone central office the Digital Communication Chapter 5. 4. Subscriber analog line is passed through an anti-aliasing filter. The band-limited signal is applied to a codec, which convert it into DS0 signal. 24 DS0 lines are multiplexed into a DS1. The telephone companies implement TDM through the hierarchy of digital signals. This is called as digital signal service. Multiplexed signal is converted into a frame at the DS1 or T1 level. B. State the principle of orthogonality. Explain the concept of single carrier and multi-carrier system. ANS, principle, 2 mark, two signals are said to be orthogonal if they are independent of each other in specified time interval, and do not interact with each other. It is possible to transmit multiple signals over a common channel, without interference, and get detected on the receiving end without interference. In FDM we have different channels occupying different frequency band with a guard band in between to avoid interference between adjacent channels, but this makes FDM a BW inefficient system. The BW efficiency improves considerably if we use OFDM technique, instead of simple FDM. The subcarriers are placed at the null points of all other subcarriers. This automatically eliminates interference among the adjacent subcarriers. Due to this, total BW of OFDM system is much less than that of the conventional FDM system. Single carrier system, 1 mark. In order to use the available radio spectrum efficiently, in single carrier system, the modulated subcarrier should be placed as close to each other as possible without causing interference. Guard bands are required to be inserted between adjacent spectrum to avoid interference, but these increases bandwidth and reduce spectrum efficiency. Multi-carrier system, 1 mark. Digital Communication Chapter 5. 5. Both the problem of multi-carrier system can be solved by using a multi-carrier system. OFDM divides available spectrum into many subchannel. Then by making all the subchannel narrowband, it is ensured that all channel experience flat fading. This makes equalizing very easy. In OFDM a DSP-based technique is used which allows a overlapping of adjacent spectrum without causing interference. 3. State need of multiplexing in communication. ANS, relevant correct answer, 4 marks, need of multiplexing. In telephone systems, there are large numbers of users involved. It is not possible to connect separate wires from each subscriber to all other subscribers. It is very expensive and increases complexity. Instead, we can use a communication medium, such as a coaxial cable or optical fiber cable, to carry many telephone signals from different sources together. This can be achieved by multiplexing. 3. Draw and explain block diagram of time division multiplexing, TDM, and state its advantages, MIN 4. ANS, TDM block diagram, 3 marks, explanation, 3 marks, any 4 advantages, 2 marks, diagram, TDM block diagram. Or Digital Communication Chapter 5. 6. Note: TDM transmitter or receiver with explanation should be considered and given marks. Any relevant diagram should be considered explanation process of combining digital signals from several sources, whereby each connection occupies a portion of time in the link is called Time Division Multiplexing, TDM. Links are sectioned by time rather than frequency. Data flow of each connection is divided into units. In TDM, data units from each input connection is collected into a frame. I.E link combines one unit of each connection to make a frame. If we have n connection, a frame is divided into n time slots, and one slot is allowed for each unit. I.e. n input connections, n time slots. One for each input line. If the duration of input is t, the duration of each slot is t/n, and the duration of each frame is t. Data rate of link must be n times the duration of a time slot to guarantee flow of data. Time slots are grouped into frames, one complete cycle of time slots, each slot dedicated to one device. A simple TDM process for 3 different data transmission is shown above. Here, all 3 data are divided into equal time slots, also called as units. And each data unit from all 3 data are combined/multiplexed together to form TDM frames comprising of small units of all 3 data, which is further transmitted. 1. Explain basic working principle of code division multiple access technology. ANS, diagram, 2 marks, explanation 2 marks, explanation. In CDMA, more than one user is allowed to share a channel or sub-channel with the help of DSSS signals. In CDMA, each user is given a unique code sequence. This sequence allows the user to spread the information signal across the assigned frequency. At the receiver, the signal received from various users are separated by checking the cross-correlation of the received signal with each possible user sequence. In CDMA, as the bandwidth as well as time of the channel is being shared by users. In CDMA, the users access the channel in a random manner. Hence, the signals transmitted by multiple users will overlap both in time and in frequency. CDMA does not need any synchronization. Digital Communication Chapter 5. 7. Or 5. Write any 4 specification of T-carrier system. ANS. Any 4 specifications 4 marks. Least lines come in 2 configurations, T1 and T3. A T1 line offers a data transfer rate of 1.54 million bits per second. 2. A T1 line is a dedicated connection, meaning that it is permanently connected to the internet. 3. This is useful for web server or other computers that need to be connected to the internet all the time. 4. It is possible to lease only a portion of a T1 line using one of 2 systems, fractional T1 or frame relay. V. You can lease them in blocks ranging from 128 kbps to 1.5 megabytes per second. 6. The differences are not worth going into in detail, but fractional T1 will be more expensive at the slower available speeds, and frame relay will be slightly more expensive as you approach the full T1 speed of 1.5 megabytes per second. 7. At 3 line is significantly faster at 45 million bits per second. 8. Leased lines are expensive and are generally used only by companies whose business is built around the internet or need to transfer massive amounts of data. 5. State WDM techniques and write its 2 advantages. ANS, WDM technique 2M, any 2 advantages 2M, any relevant diagram shall be considered. WDM is referred to as wave division multiplexing. 2. WDM involves the transmission of multiple digital signals using several wavelengths without their interfacing with one another. 3. WDM is a technology that enables many optical signals to be transmitted simultaneously by a single fiber cable. 4. WDM is accomplished by modulating injection laser diodes that are Digital Communication Chapter 5. 8. Transmitted highly concentrated light waves at different wavelengths, i.e., at different optical frequencies. WDM is coupling light at two or more discrete wavelengths into and out of an optical fiber. Each wavelength is capable of carrying vast amounts of information in either analog or digital form, and the information can already be time or frequency division multiplexed. 6. The carrier with WDM is in essence a wavelength rather than a frequency. 7. The wavelength spectrum used for WDM is in the region of 1300 or 1500 nm. Advantages: A wavelength division multiplexed WDM system is one where, typically in order to increase system capacity, multiple optical carriers, operating at different wavelengths, share a common optical fiber. 2. A WDM system can be simple, operating at two very different wavelengths, such as 1310 nanometers and 1550 nanometers, or more complex whereby 4, 8, or even more optical transmitters operate with very small wavelength separations. 3. The amount of data being transmitted can be significantly increased without increasing the number of fibers or repeaters. Hence capacity is more. Digital Communication Chapter 5. 9. C. Explain the XIT digital multiplexing hierarchy with block diagram. 8. MANS diagram. Explanation. In this hierarchy, the first level of multiplexing involves 30 numbers of 64 kbps Pcm ed voice channels. This gives a 2.048 megabytes per second digital signal. For such signals are multiplexed in the second level multiplexing to obtain an 8.448 megabytes per second digital signal. The third also involves only 4 inputs to give a 34.368 megabytes per second multiplexed signal. For such signals are multiplexed in the fourth level multiplexer to obtain a 139.246 megabytes per second digital signal. Again, 4 such signals are multiplexed in the 5th level to get a 565.148 megabytes per second signal. List any 4 advantages of TDMA over FDMA. For MANS, advantages, any 4. 1. In TDMA, since only one station is present at any given time, the generation of intermodulation products will not take place. 2. The entire channel bandwidth can be allowed to a single channel at given instant of time. This is particularly advantageous for the digital channel, which demands large bandwidth. 3. The frequency selective fading does not affect the TDMA to extent it affect of FDMA. 4. As only one channel is being transmitted at a time, it is not necessary to separate out various channels at the receiver. 5. TDMA by default can work well with the digital, therefore it can be easily used for data transmission.